Today we will begin with sources of air pollution. Okay. So, when I say sources, broadly these can be classified in two groups. One is natural and the other is anthropogenic. Okay. Anthropogenic, we can also call this as the sources of air pollution which are more man-made. Okay. When you talk about the natural sources, okay, let's take some examples. If you can remember, emissions from volcanoes cause a lot of emissions. So are the forest fires, there could be other sources like dust storms, there can be the natural sources of biogenic source, like the plants. You see, the plants sometimes emit the hydrocarbons from there. You might have heard about Smoky Mountains. Okay. So these are some examples of the natural sources. The natural sources, if one quantifies, sometimes they can be quite large and the amount can be very, very significant. But when it comes to the anthropogenic or man-made sources, we can further classify them in 4 categories. We all know that industries cause serious problem. So there can be industrial sources, then vehicular or automobile, there can be domestic sources. Largely, we know we all do cooking in the home, and whatever fuel they may use, or you may use a very clean fuel like LPG, but that still cause some amount. Well, amount can vary on depending on the fuel that you are using, can also cause the problem which is associated with the domestic. Okay, so let's call it domestic sources. And the other sources which we sometimes refer to them as are the area sources, which we can club them, put them together in an area what sources are taking place, which may be sometimes a mixture of many sources. Okay. So we'll talk about these sources in this lecture and the coming lectures. But these again, if whatever you might think these sources are really, they can further be divided, okay, in 2 components, each one of them. Okay. And a very interesting category for these two, why interesting, as we will see in a moment. One is the regular or process related emissions, okay, and the other category can be what we call as fugitive sources, or sometimes also referred to as non-point sources. We'll go into the specific details of this, but their regular sources are more through chimney or a defined duct or a vent through which the actual emissions are taking place. So, these are the regular sources through stack, if I can use the word, or even you can also think of the tailpipe emissions. What it really means is the sources which are channelized and emitted like a regular source. Fugitive sources or the non-point sources are those sources which do not necessarily go through, or which do not in fact go through the chimney or through the regular means. One simple example as I am teaching you is, I will give you example straight away of the fugitive source. As I am writing here, there is a little bit of dust from this chalk is generated, and this chalk, no matter how small is the emission, this can also be referred to as the fugitive sources. So, we will get into these specific things as we go by in this lecture, but let us talk a little bit about the fugitive sources or the non-point sources, because sometimes they are of great significance, not only great significance, but they can be of a major contributor, and sometimes we do not even know that problem exists. We keep on looking at the tall chimneys and think, oh look, there is a pollution, but sometimes these little tiny sources can be a major contributor, and in fact they are the one which largely sometimes may decide the air pollution or the air quality that we are breathing in. So, we need to understand these very well apart from the sources which we see in the regular pattern. Once we move before to the fugitive sources, let us also talk as to why we are not putting so much of stresses on the natural sources, whereas the natural sources can sometimes be in quantity can be very high. Why is this? That normally these emissions may be large, okay, but in sense of the local air quality, what people breathe, okay, these sources are not so contributory at the local level. What I mean to say is that suppose there is a volcano which is likely to erupt or which is very active, there won't be many people living in that around area. So is in the forest, that many people will not be there. But these sources, okay, which are more man-made, they are occurring in very vicinity where we live. Okay. We live, the industries we can see, the vehicles will be all around us, the domestic cooking, well, we can't live without food, so that would be there, and so will be other small tiny little sources that would be continue to be there. So, we tend to put more emphasis on these sources rather than putting the emphasis on the natural sources. Of course, they do have significance in terms of the global sense, okay, but when we talk about local air quality, these sources are far more important than the sources what we see in the natural category. The other issue, of course, which is technological limited or engineering limited problem, because these sources there is very little we can really do to control them. I mean, there is no way that I can control a volcano and its emission. Okay. So, when the engineering solutions are not there, then it becomes extremely difficult. So is the forest fire. Okay. So, then keeping the focus on man-made, and within man-made what generally people tend to ignore is the fugitive sources or the non-point sources. Let us talk about the fugitive sources, because that is a tendency to ignore. Not even many textbooks would like to cover this, because that is where we see and that is where we tend to recognize these are the sources. So, let us talk about the fugitive sources. What I would do is to make a little sense of the fugitive sources, I will start writing some of the sources of the fugitive emissions. Okay. So, that we get a little feeling that these fugitive sources are lot many, okay, sources which specifically we are talking about as fugitive sources, fugitive or non-point sources. For example, paved or unpaved road. We all see the vehicle moving on the road. Of course, there is emission from the vehicular tailpipe, but as it travels on the road, the dust which is there on the road, or the dust because of the friction between the tire and the road cause lot of emission. Okay. So, that could be one example of the fugitive source. We also see every time the building construction activities. So, building construction, and you see the way the contractor and the people spread all the building material all over, the little wind blows and there will be dust emissions. Okay. The building, not only the construction activities, it is also the building demolition. That can cause serious air pollution. Let us also take some more example. We say the loading and unloading operations. Again a simple example, the construction activity is going on, or industrial activity. Suppose somebody is loading the cement bags and you see the emissions everywhere. Okay. So, loading is just an example, but loading and unloading can be related to anything. Unloading can be related to organic solvent. Organic solvent is being transferred from one container to another, and there will be emissions of volatile organic compounds. So, we should always be thinking the loading unloading operation can also give the serious, and we will see a little later how the loading unloading can be a serious issue. Let us also look at the agriculture activity. For example, I am just writing as they come to my mind, and in fact anyone can little bit think, be a little observant, go around and see what are the sources. Okay. And of course, there is no way one could completely list down all the fugitive sources. It is just matter of your own observation, seeing the things, observing things and making sense. Look, this is causing serious air pollution problem. Okay. Agriculture activities. You must have seen the farmer spraying the urea for that matter. Okay. Or they are plowing the field, or in fact they might be spraying the pesticide. Okay. See, some of the pesticides, in fact many of them are volatile. As he is spraying the pesticide, this pesticide become volatile and they become part of the emission in the as a part of the air pollution. So, these activities, okay, as I given this some example, let us write one at least so that we can remember it. Spraying of pesticides rather. Well, we can take some more example. Refuse burning, very common problem in most of our cities. There is a refuse. People collect the garbage, their house, or even some of the industrial units will cover some of the garbage, and what they would do is put it outside, set it on fire, and they think this is the best way of disposal of that. It causes serious problem as far as the air pollution is concerned, and this all will fall into the category that we are trying to emphasize on is the fugitive emissions. Okay. So, refuse burning, even this the little ordinary stuff we do is all the leaves that fall from the tree from the fall period or during the basant time, we'll collect them together, okay, set it on fire. Okay. Leaf burning, if we can also see. See, many of the cities in our country, they don't have the proper disposal of municipal solid waste. We can also refuse, also we can refer to this as, I'll write the short form as MSW, municipal solid waste. So, what they would do is that, well, they can't dispose it of. If they don't dispose it of, it's going to degrade, it's going to cause a lot of emissions in terms of bad smell and things like that. Sometimes the people find it easy to set it on fire, okay, without knowing, and that this also causes serious air pollution. We also have seen in the winter time people burning the tires, for example, to heat themselves up. So, these all will come under the category of the refuse burning. Let us take some more examples. I could also say the smoking. Okay. can also come into this category of the fugitive emissions. Okay, the cigarette smoking for that matter, that also would come under this category. Let's see if we can remember some more of the fugitive sources. Okay, if you go in the industrial plant, material handling, well, to some extent we cover that in the loading and unloading, but material handling can be a serious fugitive emission. Not only the material handling, even material storage. What I mean by storage is that suppose you are storing coal dust, the coal which you are going to fire it somewhere, and then the conditions are like summer condition, lots of wind, and you will see a lot of coal being emitted in the air. So even the storage can be a major issue. Okay, some more example. Let's fill up this board with examples. Material handling, storage, smoking, refuse burning, agriculture activities, loading, unloading, and things like that. We should also not forget the emissions that may come out from the industrial area, from the leakages. Leakages of what? There could be valves which may leak. There could be joints that leak and cause air pollution. There could be flanges that can cause serious problem. Okay, so I can, it's just matter of again repeat that again it's so difficult to write down all these things. It's a matter of one being smart enough to observe these sources, okay, and to say, well, these are my sources. The another example I'll give you, which was very interesting, was the source emissions from lawn mowers. Okay, sometimes the huge gardens, the parks, and the people are, you know, like cutting the grass, and they use the lawn mowers which are like engine and motor driven, and then see a lot of emissions occurring from there. Okay, and this most of the time it is found the lawn mower engines were that of very bad quality, and sometimes the emission can be very, very large. We will a little bit get into the more of these things with a specific to an industry to give you more feeling about the industrial non-point or fugitive emissions. But let's also see as to why we are putting so much time and efforts in trying to understand the fugitive emission. Okay, I can also add some more important emissions of the fugitive emissions. Okay, what could these emissions really be is the emissions related to auto exhaust. What I mean by the auto exhaust is a tire which is on the road, there is a tire wear. So whatever is inside the tire, that can also come out. Okay, so that can be another significant source. I can also give you some more the idea about the emissions of the non-point emissions from the for example, sewage treatment plant. Okay, you all know the wastewater treatment takes place, and the wastewater treatment plants are the good source of H2S. They are the good source of the volatile organic compounds and the odor causing substances. So it's just a matter of you yourself realizing that what the source is. So before we go a little bit more into the details of this one, let's see what is the significance of the non-point sources. Okay, the significance, one of the most important thing about the sources, the most of the fugitive emissions will be at the nose level, if I can say that. Means wherever you are there, the emissions are at just this height, the breathing level height. So it can, you would be likely to breathe that emission much more than probably the emission which is occurring from chimney or from the tall stack. Okay, so this is what is the level. So nose level means the impact is high. Okay. The other major problem is the not taking them seriously, not taking the cognizance, not taking cognizance is not taken. The problem is that we are born with the sources. As we have grown up, we have seen those things to be there. So we don't find them anything different than what we see it every day. So we don't even recognize them, don't even take them seriously. The cognizance becomes very difficult. Okay, we have the tendency to look something as a chimney, and we say, oh, that is a problem. Okay, so we have to take the serious view of the physical emissions. The next thing is that what is the other importance of this thing is the quantification of these sources is a little difficult because they are occurring in a large area, and you don't know where to really go and measure and say so much is the quantity of the emission, because for the controlling the emission, first you need to know is how much is the emission. So quantification is difficult. The other thing is poor regulation for the control of these sources. The laws, okay, the environmental laws, more pertain to chimney, more pertain to larger sources, and no one would talk about some dust being emitted. Okay, so there is no regulation. So if there is no regulation, the industry, the people don't take it seriously. So we have to have good regulation to even to talk about the physical emissions. Let's also talk some more importance. See, as you have learned and you will learn, that idea of once we have the emission is to see how they disperse, okay, and how they go and impact the people. So that is what is a process of describing the emission, its transportation, and its impact to the people. That's what we call as a modeling. So when the sources are not so well defined, okay, so that becomes the modeling or to finding out the impact becomes very difficult. Modeling means I am referring to the air quality modeling is not difficult, but let's use the word difficult. So that's difficult. So that's what is another problem. And in my opinion, the major problem with this one is in a cumulative sense. They may be small 5,000 sources, and we don't take it seriously. Put them together, they may be larger than, for example, a large power plant. Okay, so in a cumulative sense, or in the total sense, okay, is very important. Okay, we would now, what we would do is, as we are discussing these sources, very quickly I'll write few points that what we can do to control these sources. Control, okay. We'll talk simple options, okay, and what these simple options are. What it really needs is good housekeeping. Okay, keep the things clean. Okay, don't let such thing happen. Good housekeeping means you are constructing a building, you have all the building materials, cover the whole area, so those emissions are not going out. Okay, if possible, the other options can be, if possible, maintain little moisture level in the raw material that you're handling. That's a big help. Maintain moisture in material that you're handling. Well, I'm not saying necessarily maintain moisture in everything. That cannot contain the moisture. For example, well, you are handling a cement, let's say, and I am not saying that please maintain some percent of the moisture in that. That will be disaster. Okay, they maintain the moisture in the metal handling. Okay, regular checks of your flanges and walls, because sometimes these fugitive emissions are simply not the pollution, it is your own resources, your own raw material, your own product. If that is being lost, then well, economically you are doing a very poor job. What else can be done? Channelize them if you can somehow. If you channelize them, there is a good possibility that it can be controlled. Channelize the emissions. Enclose the area where you are doing such operations. Enclose the area. Simple thing. More options you have is provide what we call as a windbreakers. That's something that will slow down the speed of wind. As a result, the emission from your storage area will sometimes go down. Provide shelter belts. Okay, I'll explain you what shelter belt is. Shelter belt. Shelter belt is smartly putting the trees around the area where you are likely to have the emission. Shelter belt is largely, you can say, the tree growing of the tree around operation where you have this serious problem. Shelter belt or planting and growing trees around the planting and growing trees around. Some of you might have gone to Taj Mahal now or some 20 years ago. There was no trees and there was no forest area. In fact, a very important decision was taken to grow lots of trees around Taj Mahal so that some of the pollution will be prevented by the trees that goes in there. Trees, not necessarily I am saying the trees will absorb the pollution or trees will filter the pollution. What really happens is that the pollution, as it encounters a tree, it is lifted up and it passes from that area and then goes away. Okay, so let's not get a feeling that the shelter belts will kind of absorb the pollution. Well, it does, but not to the extent that it can be said this is the major mechanism of the pollution control from the shelter belt is really not neither the absorption nor the filtration, but it just simply moves the air mass with the dust to the higher level and then it just disperses far away. So these are the various options people try, okay, and the more engineering options are also there, but these are general little things, you know, like you are nearby your shop where you have lots of dust. Well, what you can do is put a little bit of water all around, if you have the water, I mean, you know, like, and you don't need to have very high quality of water. Spread that around, and you must observe that, you know, the shopkeepers which are there, and because they are the one who's exposed so much because of the dust, because the vehicle is moving, somebody is moving around, and the dust. They on a periodic basis, what they do is the simple ordinary thing: put a little water around their shop and things like that. It gives you little good smell, as well as it also prevents a lot of dust emission that can possibly come because of small things, but the important things. Sometimes the smaller options are better options and more doable in that sense. So what we will do is stop this discussion of fugitive emissions. This is everyone to observe, or everyone to do something about this one, because they are significant, they are important, they cannot be ignored, and moreover, nose level and in the cumulative sense, they can be really a very significant and a large source. Okay, what we would do is, the idea is that we go to an industrial process, okay, talk about the industrial emission, and as well as in that industry, let's little bit talk about the fugitive sources, because fugitive sources, as I said, can occur not only in the urban area, but it can also occur in the industrial area. So we'll move to the industrial sources, and then what we are going to discuss is what we call as the thermal power plant. We all have seen the plants which are producing the power, and there are lots of environmental issues related to emissions which are through chimney, and the emissions which are fugitive in nature. So we'll move to the next thing, and I'll take help of the computer graphics to talk about that. Okay, now what we will do is talk about the industrial air pollution sources, and one of the major air polluting industry is the coal-based power plant. So we'll focus on coal-based power plant, and it's also important to study this industry as we are a growing economy. We are producing right now about 100,000 megawatt of power, or the installed capacity is about little over about 100,000 megawatt. And we also planning, because we all need energy and electricity, we also planning that this the government is planning that this capacity is doubled, something like 200,000 megawatt, a major effort that would be, and in the process, and the plan is by 2015 we produce, or we have the power plant capacity of generation about 200,000 megawatt. And it will be interesting to know that almost around 65%, of course this number can vary, 65% can be coal based, and rest can come from other sources. So the coal based power plant 65%, let's use that word here, percent, it will be the coal based power plant, because we have lots of coal and we want to utilize the coal for the power generation. Nonetheless, the issues related with the coal-based generation are many, especially the air pollution thing. We all have seen the tall chimneys, and in fact, in the country, the tallest chimney that you see is from large power plant. You will be surprised if power plant of 500 megawatt capacity will have a stack height, or the chimney height of 275 meters. So what I would do is that go through the process and try to identify the sources as we proceed in case of the coal-based thermal power plant. So what we're going to discuss now is the coal-based, as we call them, thermal power plant. So let's move to how the power plants look like. Okay, you see the little thing there on the top, how the plant works. So let's go through the process of the power generation. This is the baseline I'm showing. The first of all, you see a little thing which is coming on the corner of the screen is the bringing the raw materials that are required. Largely this raw material is a coal, and it can either come from the ship or from the mining area where the mines are, and through the railway wagons this coal is brought to the power plant. You would also see that immediately this coal which is there is dumped and stored, the coal storage. Okay, the next step in the operation is that there's some kind of coal storage and some primary crushing. Okay, if I can say here, primary crushing is done, and the coal is transported through the conveyor belt. What you see here, the strip which is going here is essentially the conveyor belt that will take the primarily crushed coal to what we call as a bunker, or storage of the coal. Then what we do from the storage of coal is further take it to what we call as the coal mill, because now we want to make the coal still finer. And how do we make the coal finer is to take it to the ball mill or the coal mill, and essentially most of the time it is a ball mill. You use huge steel balls and put into the large container, and the whole thing is rotated, and the ball is keep on falling onto the coal, and in the process the coal becomes very fine. So then once the coal is fine, almost of the size of, let's say, anywhere between 20 to 100 micron. So then now once the coal is sufficiently fine, because we are not talking a great deal about the combustion engineering, but what we are saying is that once the coal is powdered, or the technical terminology is from the coal mills, what we get is from the coal mill, what we get is what we call as the pulverized coal. So this pulverized coal can be used now in the for the combustion or to obtain the energy. And how it happens is that what you can do is the coal from the coal mill, the outlet from the coal mill will go to the boiler, or this is the little firing area. What you see is the, and then apart from the coal, the air is supplied, and the pulverized coal burns very well, giving you the high temperature, high energy. And then what we do with this energy is to have a system of the water tubes. You can't see really very clearly here, but you can see here they are the tubes which are filled with the water, okay, and the heat that is generated from the boiler is the tubes, which we all know. It's kind of a water tube boiler. So the water which is heated here, and then steam is generated and steam is passed through this area. So what you can say is this is the outlet of the stream as steam, as you will see here. So let's write this as the steam, so that is going out, okay. Then what happens is this steam goes and runs a turbine, okay, that you can see the turbine here with a steam jet hits to the turbine, and the turbine is rotated, and in the magnetic field what you get is the electricity, and it eventually is produced as a generator, as you can see here, the generator here, okay. And then you have the steam which had a lot of energy. After having done the job, the steam must be cooled down, as you can see here, and after how the cooling is done through the condenser cooling. So what you see is this thing is basically this is a condenser. How the condenser really works, because this also has the environmental issues. You take the surface water, or it could be the water from sea. So the surface water, suppose there is a river here, and then you are pumping the water, and then provide a large surface area, and this cool water, which surface water is relatively cool, comes in contact, not the water but the surface, which comes into the contact with the steam, and steam, as a result, steam will condense, okay, and make the water here, and this cooling water is in a closed circuit here. It doesn't come in the contact with the steam, is taken out and is disposed of back to the wherever the source which was there. So one of the issues here, what you see here is the surface water was, like, say, at some temperature T1, and by the time it has done the cooling operation, its temperature goes up, and this temperature becomes T2, and T2 minus T1, or we can call this as the delta T, is the rise in the temperature of the cooling water temperature. So this also causes what we know as the thermal pollution of the receiving water body. As you can see here, there will be rise in the temperature, and in fact it affects the ecology here, and the fish and the other important ecological functionaries would tend to migrate away from there and change the ecology here. So this is one of the issues of this one. So we should try that the rise in temperature is not very high, or we do some kind of treatment to bring down the temperature T2, something very close to the receiving water body, which may be a river, or even in fact a lake, okay, or it can be seawater for that matter. So all right, this is a little portion of the water pollution problem, but let's see what further things happens in the power plant. As you can see here is you also need at times is the makeup water, because all the steam at some point, like, will not be enough. So you see here the word industrial water. So industrial water needs some cleaning, okay, especially all is to make it demineralize, take out the hardness and bring it up here and do the makeup water. So more like industrial water is a makeup water, as you can see here. And this water, once after the steam has cooled down into the condensed into the water, this is further pumped from here and back to the boiler. And these are the, again it goes through the process of heating from the boiler, and the entire water becomes steam with a lot of supersaturated steam or superheated steam rather, steam, so that it can again produce the power for us, and this cycle kind of goes on and then the power is generated. You can also see, and then eventually the power through the various transformers is eventually transmitted. But that part is okay, but let's talk about something else. And then all the power plants, as we were discussing about the green belt, most of the power plants will have a green belt around this, okay, largely to tackle fugitive emissions or to give the better ambience to the power plant. Okay, so let's further go. Let's come on to this side, which is as to what else is happening. What you would see here in the boiler, okay, once you are burning the coal, there will be ash will be generated, because ash is something which you can't burn really. So what will happen, some ash will immediately fall down here, okay, and this ash we call as a bottom ash. Why bottom ash? Because it's the bottom of the boiler. Then what happens, the ash which would not settle here or would not fall down here will be emitted from the process and will go to some process. We'll discuss this one, and this ash we will call this as the fly ash. And this one was as I said, that ash from the bottom of the boiler is called the bottom ash. So maybe I can tell this as BA, that we are referring as the bottom ash. The bottom ash, immediately the bottom ash should be collected at some intervals and stored in silos, okay, and then needs to be disposed of. The disposal is a little important, because as you will agree with me, that apart from the coal, apart from the carbon, hydrogen which you can burn, you also have the ash, which is largely silica that cannot be burnt, and you also have many of the metals present in the coal, and these metals which are present in the coal will eventually, most of them will stay with the ash. So the disposal becomes a little issue, and so the fly ash is a major component. To give a little feel, that fly ash generally for such power plant, fly ash generally 85% of the total ash, and the bottom ash, or as I call that as a BA, is around 15%. Okay, but fly ash is really very fine. Okay, the particles are very fine, much finer than the particles that we had created at the first place, that through the ball mill or through the pulverized coal. So this is the particle. If you see the particle size, especially what you had fired in the boiler, and the particles which are generated, particle size which are created or formed during the fly ash, these particles at the fly ash, or particle size I mean, is much smaller and more problematic for both from the public health point of view as well as from the control point of view. So let's say what the control mechanism that we have. Apart from the ash, you will recall from the combustion process that some of the or some is significant from the air pollution point of view. NO2 is also NO or NO2. In fact, it's mostly the NO. So we should really call this as the NOx. NOx is also emitted, and the first thing what we do even before fly ash is that NO2 is controlled, and the process of control of NO2 is really we call as SCR, selective catalytic reduction, that we will see little later when we talk about the control. But at this stage it's reasonable to know that the NOx must be controlled, because NOx is a serious problem through selective catalytic reduction, and mostly what you use as a selective catalytic reduction is the ammonia is used. Selective reduction is based on using the ammonia to reduce the NO2 or NOx into nitrogen and oxygen. The first part you do, but let's not forget that this thing we still have the fly ash. So the rest of the process is then once the NO2 is controlled, then you can bring it to the control of the particle matters. So all the fly ash is controlled here. So if I can say here, control of fly ash, and what you see here, once the fly ash is collected, and the mechanism through which we collect the fly ash is what we call as ESP. They are called electrostatic precipitators. You can also use the back filters, but these technologies we will talk a little later, but let's understand the process. Through the ESPs, most of the fly ash of the order of the control of the fly ash, you will be surprised that the amount of the fly ash that we can control is of the order of, or even sometimes greater than 99.99%. So as a result, you don't want to see your chimney being emitting anything. Your chimney should look rather very clean. So fly ash is collected here, and once it is collected at the bottom of the hopper of the ESP, and it is again collected in the silos, as you see here. They are the fly ash silos, and then they are put into the trucks, okay, or these could be put into the wagons of the railways, and it can be transported back. It might be interesting to tell you is that these fly ash, earlier there was a serious problem of the disposal of the fly ash. Now this fly ash can be used in the cement plant. Okay, cement plant are very happily buying the fly ash from the power plant, blending it with the cement that producing, and finally making the cement that is used in the construction activities. Well, this is the story of the fly ash, but sometimes the fly ash, if it is not collected, not put into the trucks for the reuse and recycle, sometimes the fly ash is disposed of through the wet slurry. It means what we do is we make the slurry of the fly ash that is collected and dispose it off onto the fly ash ponds. Well, apart from the fly ash, now let's not forget that also the emission of the sulfur dioxide that takes place. So if I can, in fact I may mention here the major sources of the pollution or the air pollution from the power plant is the fly ash. Let's call that as FA, and we also have seen that NOx is the other source, other pollutant, and the next pollutant, which is again of great significance, is SO2. So in the plant, what we're trying to do is, first of all, the NOx was removed, as you can see here, NOx is removed, then the fly ash is removed, you can see here the fly ash is removed here, and the next step is to control of the SO2. So here you see SO2, and the plant which controls SO2 is called desoxing. I hope you can read here, desoxing or desoxing plant. And how do we do the desoxing is a process. We use the lime, or we use the calcium carbonate, and calcium carbonate will react with the sulfur dioxide, and especially with the temperatures that we have, and it will produce calcium sulfate, and SO2 will be completely removed from the process. And then again, whatever the dust that might even come out from the desoxing plant, again you have the ESPs, and the ESPs will again remove the particles whatever that might have carried over from here, and then finally once the entire cleaning process is done, then we let the flue or the flue gases out through the chimney, and these are generally the tall chimneys, as you can see here, that can be anywhere from 150 to 275 meters. So this is the process of the power generation, but here we have just focused on to the emissions that are more of the boiler related emissions. Okay, what are the emissions? Fly ash, oxides of nitrogen, and sulfur dioxide. So these need to be treated before that can be sent out through the chimney. So this is the process. If maybe very quickly we can repeat the process. The coal is brought down, stored, and the coal is primarily crushed, sent back to the bunker where they are stored, and the bunker they passed on to the coal mill. where they are further crushed to the down to the small size in the micron, and then these are the fired along with the air, and in the process firing you have the water tube. It's a water tube boiler, so the steam is generated, superheated steam comes, then it goes to the turbine. Turbine is rotated because of the steam hitting to turbine blades, and then it is connected to the generator, so you get the power, and the steam is condensed, and then what is used for is the condenser cooling water. The water is normally taken from the nearby source. Cooling is done, high temperature water is disposed of back from the source, and the emissions that occurs from the combustion are the particles, particulate matter, which is again divided in two parts. One is fly ash, the other is a bottom ash, as we called here BA. Fly ash is about 85%, BA is about 15%, and then the flue gas is subject to the treatment for the removal of oxides of nitrogen, fly ash, which is particulate matter, and the sulfur dioxide, and the clean air or the clean gases are let through the tall chimney. So this is the process. So this is we have seen how the power plants generally works, and what are the emissions, what are the control that needs to be done. But don't forget that we were talking about the fugitive emissions. So let's discuss the fugitive or non-point sources from the power plant. Well, if you recall, we were discussing about the fugitive emissions, and then we also listed the significance and the reason we should study the fugitive emissions. The fugitive emissions are not only in our daily life that we observe. Fugitive emissions are also an important issue in the industrial processes, and then to demonstrate one, we would take an example of the power plant, because we have studied the regular or chimney emissions from the power plant. So let's talk about the specific emission of fugitive emissions from the power plant. And again, I'll quickly give you the definition is a pollutant generated from the open sources exposed to air and are discharged into the atmosphere without confined flow stream. What mean by confined flow stream is that, well, they are not from the chimney, they are not from a duct, they are in more like an open thing. To give a little feel, see here the picture that has come up on your screen is that you will see that, well, the coal is being stored. Okay, what you see here is coal is constantly falling down on this one, like it makes a heap here, and as the coal falls, there is a possibility of the emissions that may occur from here. The coal dust will emit like this from both the sides, and then this can cause very significant emissions. And apart from that, if the wind is blowing like this, let's call this as W as an indicator of the wind, and the wind is here, you will see some dust also coming in the sideways. The problem, as we have discussed, is difficult to quantify. We don't really know as to how much would be the emissions. There are no regulations. The government or the system so far doesn't say as to how much emission is to be controlled and how this is to be controlled, and how to put up the condition to see if this is being controlled. So that's difficulty, and no doubt about it, we have put enough emphasis in this course, as we need to really have the attention, understand the problem, quantify it, and control it. So these are the just an example, just to introduce you into the subject of the fugitive emission. What is the approach for the if you want to assess a fugitive emission? What you do is that you should identify the potential sources for the in-depth study. I mean, take a little nice round of the power plant. Go around, look for everything, and be a little observant. Go around, if I can say the word, go around the plant. Okay, identify the suitable methods for each source. Now we have to quantify the source. How much is the emission? So then then we will learn to some extent for different kind of fugitive sources the methodology that is required to estimate or to quantify these sources is different. So we also need to see, well, what method that we want to apply to quantify that. What method? Okay. Then once we have the method, suitable method, we need to do the sampling, as you can say, identification of suitable sampling methods. Okay, sampling size, how much is the sample that you want to take, so that is quantifiable. Type of samples, is the long term sample or the short term samples, and then what are the materials required for the sampling. You need to take, sometimes you need to take sophisticated instrumentation to the field, to the kind of samplers that you need, that you should know beforehand, kind of samplers. And then you also identification of suitable mathematical models. Sometimes you will see that apart from the measurements that we do, we also have to apply some models for the estimation. So what kind of models? So we will also see that what kind of models, and let's put that as a question mark, because we are going to see that. Then you do the sampling and the data collection. Fine, that's what is the thing we are aiming at. And then finally, which is very important, is to estimation and the interpretation, what it really means, and then we'll do it with some example, and hopefully we'll be more clear as to how one can handle the issue of fugitive emissions.